this is still the biggest space weather event that we know of. We have some magnetic records because there were stations around the globe that were measuring the magnetic field and perturbations to the magnetic field, which is one of the basic things that happens during space weather. It's a dog avalanche. And you know why we had all these magnetic records going back to the 1800s? It was sailing ships. Sailing ships use magnetic compasses to navigate. And so people put these magnetometers all over the world, mostly British colonies, like India, places. And so we actually do have some data from this Carrington event. And one of the things that we're working on at the lab right now, and other people across the country, are what would happen if we had a Carrington-like event again now? You know, we talk about the 100-year flood, and you know, Boulder had a 100-year flood 2 years ago, right? 100-year flood happens on average, I would say, every 100 years. This Carrington event, that was only a couple hundred years ago, right? I mean, that shouldn't be, you know, if we're thinking about what's the 100-year event, it's probably something along those lines. And this is one of the, excuse me, I obviously need more wine. This is one of the reasons why we, for the first time in the country last year, have a National Space Weather Action Plan. The President signed an executive order to direct federal agencies to start doing a lot more, to anticipate and plan for big space weather events. With the caveat that we should do it with the same amount of money that we were allocated.
So the somewhat literal burning question is, when are we due for another one of those? Do we have any idea?
And secondarily to that,
Yeah.
is there a history of mass extinction events?
Ooh, that's a cool question. So,
Or just, extinction of one very important species?
no, but it'd be a really bad day to be text messaging. Basically, anything that involves electricity or modern technology, you don't want to be doing on a bad space weather day. Because, I mentioned that plasma is all, electrified. So when the aurora, you imagine these electrons are coming down, they're hitting the atmosphere, they're making it glow. They're also carrying a current. And that current then flows through our ionosphere. It induces currents in any kind of long conductors like transmission lines, telegraph lines, undersea cables, pipelines, and it drives these huge currents. Sometimes it burns out transformers. This happened, there was a big event in Quebec in 1989, burned out transformers. Bad thing about burning out transformers is it takes a year to replace them. So you burn out too many transformers, and now you start to have a national level catastrophe.
Well,
we try not to do the whole Chicken Little thing too much, but how likely is it to happen? It is, I would say, something like the Carrington event is almost guaranteed to happen sometime in the next couple hundred years. And I would say that it is very possible it'll happen in our lifetime.
Yes.
But we don't know how possible. One of the things that we're trying to do is trying to do the statistics on other things. So the Carrington event happened in a not particularly big solar maximum. It happened at a not particular, we don't have data sets that go back far enough. I mean, we launched Sputnik in, we didn't launch Sputnik. the general
The people.
we. This is humanity.
Fake news, fake news.
Humanity here. 1958 wasn't that long ago. Well, I mean, it's kind of, I wasn't here,
That was fun.
but we don't have a lot of space data. We don't have a lot of space data, and we don't have a lot of proxies for the kind of space data that would indicate a Carrington event. It's not like ice cores or things like this where we can, make the climate record go back for thousands of years. So there's a lot of we don't know.
Well, I think, it's going to happen, so, when. I think the salient question is, at our point in time with technology, could it take out GPS? Because that would be the collapse worldwide of so much infrastructure that most people just don't even acknowledge.
Oh, yeah.
So,
Could a Carrington event take out the GPS? That's my question.
That is good. Oh, yeah.
do you remember the physicist's answer? It depends. If you ask a physicist yes or no question, it's always, it depends. It would not actually take out the satellites themselves.
Well,
And the reason is, now, so these kinds of events do take out satellites. The radiation belts and the part of the magnetosphere that I study is the #1 cause for the complete death of satellites. It's something called deep dielectric charging. The GPS satellites are war-fighting satellites. They are designed to withstand nuclear war. And so they are hardened to an extent that they should not, they should survive.
that's a little bit reassuring.
Right. However, GPS works by sending radio waves through the atmosphere. And when the atmosphere is electrified, the radio waves don't propagate the same way. And you get big navigation errors during space weather events.
Yeah. Well, temporary we can ride through.
Temporary we could ride
If it was destroyed,
Yeah.
we're in big trouble.
Right. Now, communication satellites are typically not hardened the way that military warfighting satellites are. And so
My Twitter is going to go down?
it's not just your Twitter.
That would be a good thing, you know?
It's not just your Twitter, but if you pull on this thread about what do we actually use satellites for, when you swipe your credit card at the gas station, how does the bank know that you actually purchased something? Well, we've got local, communication systems, but you're in Greenland and you swipe your credit card. How does your bank know? It's satellites. So satellite communication is not just ESPN. It's not just telephones. It's not just internet. But it's something that we increasingly, if it didn't exist for a couple of days, would be a big problem.
Even if it takes out telegraph lines, what does it do to our power grid?
So the power grid, one of the reasons why telegraph lines were particularly susceptible is because they just strung long wires. And it's a voltage drop. So the longer your wire, the bigger the voltage drop. And that's why telegraphs caught on fire, is there was just driving so much current, it literally caught telegraph stations on fire. We now isolate our power systems and oil pipelines have insulating